talking about your lab a little bit, and you got all your categories using the method of dividing your range into the number of clusters that you wanted, and you guys did a great job graphing. So I did a fake graph with my fake data, and I made it really nice. I made it perfect. Some of you have near perfect data, some of you have some kind of crazy data, but we'll talk a little bit about what causes that. So when we look at a graph like this, so when we talk about the shape of the graph, we're kind of thinking in terms of laying a line over top of the graph. And if we laid a line over top of the graph, so it just sort of almost touched each bar, that's where we get to that shape question. So if I had to describe this one, or if you had to describe this one, what would you say? There are a lot of ways. There's not one right answer. Go for it. It's a hill. Okay. It's what? It's bell-shaped. Oh, somebody remembered a word from someplace. Ooh, it's bell-shaped. What else could you describe it as? I've heard it described as one-humped.
I have this in math class.
Okay, you're doing distributions in math. Cool. Then this is going to be really easy for you. The next week is going to be a cakewalk. Yeah, a hill, a bell, a single hump. Anything else? That may cover it. Go for it.
It sort of looks like an N if you look at it the right way.
Yeah. A mountain. An N that's missing its thing on one end, a lowercase. Yeah, okay, that got stretched out. A mound. Mound-shaped, hill-shaped, bell-shaped, a single hump. Okay, those are all valid. So when you go to answer the question about your distribution, now let me do something that I saw here. I saw a distribution that looked a little bit more like this. One of you has data that looks a little bit more like this. How would you describe that? Two-humped. Two-hilled. A camel. Wavy. What? An M that got stretched out. Okay. Okay. It has two modes. It is bimodal. Yeah. We're going to use bimodal. Yeah, this is going to be, the next week is going to be awesome for you, Chase. You're going to love this. Which math is this? Stats?
Probability and data analysis.
Probability, yeah. Stats, basically. Cool. Okay. So when you look at your data, what I want you to do is sort of put a line over the top of your data. And then that's what you're describing. And some of you are going to have, you might have three humped or two troughed or whatever. But that's the shape you're describing. Okay. So once you've done this, we're gonna talk a little bit about that last question. At what values do you find the smallest number of measurements? So here, looking at this graph of my sample made-up data, where do I find the smallest number of individuals with those measurements? We'll give somebody else a chance, Sawyer. Go for it, Jordan.
16.8 to 17.6.
And this top one, which I didn't even name. Those are the smallest ones. Very, very many of you, I would imagine, have the smallest number of individuals at the ends. Is that true? Yeah. So, I've told everybody who would listen in the last 2 days, I'm in the Stubby Fingers Club. I'm in the Stubby Little Hands Club. I could never be a hand model and model jewelry and department store advertisements because my hands look like Stubby Farm Girl hands, because they are. So, I'm down in the bottom. I'm down here for hand size. Who are my hitchhiker thumbs? There were 2 of you who had big, long fingers. Big grip. You can palm a basketball? Okay, Garrett and Dylan. I can barely palm an orange, okay? I can palm an orange. It's an exaggeration. It's a figure of speech. It's hyperbole. So, if you've got those really long fingers, those really long thumbs, you can palm larger objects more easily. You're existing somewhere up here. But the vast majority of you, guess where you fall? Somewhere in the great middle. And for most characteristics, guess where most people fall? in the middle. Now, we don't have a very big sample. What is a sample? What's a sample?
It's the size of the group that you're
Yeah. A sample, and I'll write this down. I can't get rid of that. I'm sorry. A sample. Okay, so a sample is just the size of the group that you've measured or collected data or tested or whatever. What was our sample size in here? 22. You measured 22 humans. Yes, sir. Oh, you had 23. Okay, you had a sample size of 23. I'm sorry. I thought it was 22 plus me, or 21 plus me. Okay, so you had a sample size of 23. Is that a very large sample? No. That's a pretty tiny little sample. So if we went out and measured 100 humans, do you think that your graph would look any different?
Yes.
What do you think would happen to your graph? I mean, we'd have more numbers, sure. Well, let's imagine this. Whoops, I didn't mean to get rid of everything. Let's imagine that we only measured 5 people. Let's say I take this table plus Cassandra, 5 people. And for whatever I'm measuring, this is what I get. 2 people here, 1 person here, 2 people here. It's not a great distribution, is it, for anything? We're not showing a lot of the population. It's a very small sample. Here's the magical thing that occurs. The more people we measure on any characteristic, length of thumb, length of pinky, height, head circumference, size of feet, length of nose, size of ears, anything you can select. The more people we measure, the more our graph starts to look like this. We start to get towards that one humped graph, that hill in the middle. One person in here knows what it's called. It's very often called a bell curve because it's sort of bell-shaped. What's the average person in this population? Where does the average person fall? The most average person you can imagine, gee, is somewhere in here. People down here are really exceptional. People up here are really exceptional. They're not ordinary. Are they normal? Sure, they're normal for me. Having stubby little hands is totally normal for me. I've had them my whole life. But the average for any characteristic in a population generally is somewhere in the middle of the bell curve. And this is true for any characteristic we can measure. Anything. Leg length. I don't know what. Eyelash length. Anything that's a natural sort of occurring characteristic that we can measure tends to shake out like this. This is the normal distribution for any trait. Oh, wait. You know what this is called? It's called a normal distribution. Cool. It's a normal distribution. It's the pretty much usual distribution for any characteristic we can talk about. I will move off the human species and I'll move to rabbits. We've had a population explosion of rabbits in my neighborhood this year. They decimated large parts of my garden early in the season. I've never hated rabbits as much as I did this spring. I love rabbits. I raised rabbits. I bottle-fed baby bunnies. I nursed them back to health. I have this emotional connection with rabbits. And this summer, this spring, I was ready to kill every rabbit that got within 10 feet of me because they ate all my pepper plants to the ground. I was not happy. So I've been paying a lot of attention to rabbits this year. And how many of you have seen a rabbit? Okay, if you have not seen a rabbit, you have homework. You have to go find a rabbit. Anybody here raise rabbits, 4-H or anything? I raised rabbits in 4-H. Okay, not glamorous like horses, but hey, still get to have some kind of livestock. So you know that, of course, rabbits look something like that, except they're not green. Terrible rabbit. That's okay. There's my rabbit for the day. What things could we measure about this individual organism? Oh, ear length is a great one. I love ear length. We could measure ear length. What else? We could measure whisker length. What else could we measure? Body length. We could stretch them out and measure them. What else, Haley? Oh, we could measure circumference of the tail. What else could we measure? Nose size. How wide is the nose? What else? Paw size. What else?
Length of legs.
Length of what?
Legs.
Legs. Yes, leg length. We could keep going all day. Is there variation among rabbits? Are all rabbits like now? Rabbits look a lot alike to us. The eastern cottontail rabbit. It's small. It's sort of a speckly brown. It has a white tail. It's about yay big. Yeah. Yeah. This year, with the population explosion of rabbits in my neighborhood, we have one, and this rabbit was in front of my car this morning. I went out to get in my car, I put my coffee on the roof, I put my stuff in the back seat, and I looked, and sitting right in front of my car like this was the individual that I refer to as the earless bunny. This rabbit has got ears. Let me attempt to draw my friend for you. It's a terrible rendition. I need to get a picture of my little friend. This rabbit has got ears that are probably about 1 centimeter long. It is literally the earless rabbit. It appears to have been born this way. The ears are symmetrical. We're not talking about a rabbit that's got one ear and one stump, like a neighborhood cat got a hold of it. It appears to just have been born with these little teeny tiny ears. It probably gets made fun of all the time because guess what, folks? Here's my anti-bullying lesson. You know who gets made fun of the most? I'm going to tell you who gets made fun of the most. Me in high school, but that's another story. Because I was crazy then, too. The people here and the people here. This is who gets made fun of. And guess what, people here and here? You are exceptional. You are not average. You are not existing in the great center mass here where everybody looks about the same. They all have nice little ears. Oh, no, people. You people out here, you have stubby ears or giant, big, floppy, crazy ears. And it's okay because guess what? It's normal for you. Don't confuse normal and ordinary. People out here, they're exceptional. They are exceptional. I am exceptional for my stubby little fingers. Can't palm an orange, but I'm exceptional. I can palm an orange, don't worry. Don't take up a collection to buy me smaller oranges. There is variation in all species. So what we are going to start talking about tomorrow, and as far as I know, tomorrow is a normal schedule for us. Are you holding up your pinkies? Are you making fun of me with your nice long pinky? My pinkies are crooked too. We'll talk about that when we talk about genetics. They look like summer squash. When I was a kid, I absolutely hated them. I dreamed of ways to straighten my pinkies. I thought they were weird and ugly and I should just hide them and, maybe wear gloves all the time. The things we obsess about, seriously. As a 12-year-old, I thought that these were some sort of, freakish thing that qualified me for a sideshow. Now you're all looking at your pinkies, aren't you? Uh-huh. Some of you will be in my club. When we get to genetics, some of you will be in my Crooked Pinky Club. Starting on tomorrow, we are going to start to talk about what this has to do with biological evolution. So that is where we will end it, and I hope you all have a wonderful, wonderful